Today, we're diving into a hidden force in manufacturing, a tiny, almost invisible flaw that can bring an entire production line to a grinding halt. We are talking about the science of getting metal perfectly flat. Okay, so here's a weird one for you. It sounds like the setup for a bad joke, right? What could possibly connect the sleek, curved panel of a car with a simple frying pan you've got in your kitchen? Well, the answer is that they both start out as a simple, flat sheet of metal. And for them to work the way they're supposed to, for that car door to seal tight against the wind and rain, or for that pan to heat up evenly, that metal has to be absolutely, positively, perfectly flat. And believe me, that is way harder to pull off than you might think. At the heart of this whole problem is a sneaky little thing called material stress. The best way to think about it is like an invisible energy that's trapped inside the metal. It's like a tightly coiled spring, just waiting for a chance to pop. And when it does, the metal warps, it bends, it twists, and that perfect flatness is gone. Now, this hidden stress isn't some kind of mistake or defect. Nope, it's just an unavoidable part of making things. Every single step in the process adds another layer of this hidden tension. Just unrolling the metal from a giant coil introduces stress. Cutting it with heat creates hot spots and cool spots. Even just punching a simple shape into it creates these tiny, concentrated pressure points that can cause huge problems down the line. So, you might be thinking, okay, a tiny little warp, who cares? Well, in the world of precision manufacturing, that tiny, almost invisible imperfection creates a massive, expensive domino effect. And this is where the costs really start to pile up. A part that isn't perfectly flat, it won't bend the right way, which throws a wrench into the whole assembly process. If you try to weld it, you can get these invisible gaps that create dangerously weak joints. At the end of the day, parts fail quality control, entire batches of perfectly good material have to be thrown in the scrap heap, and the whole production line gets bogged down with delays, costing a fortune in time and money. So, if stress is the enemy, how in the world do you get rid of it? And that question leads us to this fascinating paradox. How do you bend something to make it perfectly straight? The solution is this brilliant piece of engineering called straightening, and it's a really clever process that works in two main stages. Okay, so picture this. First, the sheet of metal is fed into a set of rollers that bend it, up and down, back and forth, over and over. This intense flexing basically massages the metal, pushing it to its limits and forcing all that coiled up stress to just let go. Then, once the stress is gone, it passes through a final set of perfectly aligned rollers that flatten it out, leaving it totally pristine and stress-free. Now, it sounds simple enough, right? But here's the kicker. Getting that balance just right. The perfect amount of pressure at the perfect angle for that specific piece of metal, and doing it on the very first try, that is incredibly difficult. It's less like science and more like art. I mean, just let that sink in. A critical maintenance job that used to shut down production for half a day is now over in the time it takes to grab a cup of coffee. That is an absolute game changer for any factory. And what about the rollers themselves? The parts doing all the heavy lifting? These machines use chrome rollers with a Rockwell hardness of 60. Now, to give you some perspective, a really high-end chef's knife is around 58. So these things are engineered to be incredibly tough and durable, to take immense pressure day after day without breaking a sweat. And the built-in intelligence is all about preventing disaster before it happens. Little things, like making the rollers reversible, which is a super simple way to double their lifespan. But more importantly, you have sensors that act like bodyguards for the machine. If a sheet of metal is too thick, or if it has a bent edge, the machine knows. It just stops and spits it back out, before a simple mistake can turn into a catastrophic equipment-destroying failure.